Hello students, in the last class I explained the Newton's first law of motion. In today's class I will explain an important concept that is called linear momentum or momentum. This momentum is denoted by a letter P, and this momentum is a vector quantity. If an object is moving with some velocity, let us consider an object of mass m is moving with some velocity, then that object have a character that is called as momentum. Okay. So here the momentum is defined as this P means momentum is defined as product of mass and velocity m into v, where momentum is a vector, mass is scalar quantity, and here velocity is a vector quantity. It is product of mass and velocity. And remember, here the direction of momentum is same as the direction of velocity. It's SI unit. It's SI unit, that is mass kg, velocity meter per second, kg meter per second. Then its dimensional formula is ml t to the power minus 1. How to understand the concept of momentum? Means it defines the quantity of motion. If any object is moving, means it is having mass, it is having velocity, that means it defines a quantity of motion. How to understand this concept means, let us consider a child riding the bicycle. Okay, and he will collides to a wall. That means during collision, definitely there will be some impact on this wall. Let us say it is moving with 5 meter per second. And imagine another situation. There is a truck. This truck is also, let us consider, moving with 5 meter per second. And again the truck is colliding to the same wall. In this case also, definitely there will be some impact on the wall. Comparing to this condition, in this condition the impact on the wall is more. Why? Because what differs here, the speed is same, means definitely the mass is different. Here the mass of the truck is very, very large. So we can say that if mass is more and it is moving with some velocity, it is having some quantity of motion, because of that there is an impact. So in both the examples, in this case the impact is more, means definitely we can say here the momentum is more. Or if the same child, if he moves with 50 meter per second, then again there will be an impact. Or we can say that effect of force. Then what happens means comparing to previous, this time the impact produced will be more. So what we have to understand means here, if you increase mass, momentum will increases. If you increase velocity, then also the momentum will increases. Momentum depends on mass and velocity. So I hope you understood the concept of momentum. Then write a note, that is P is equals to m into v, where P is called linear momentum. For example, let us consider the mass is constant. Okay, the mass is not changing. Then we can say P proportional to V. And in the next condition, let us take here P proportional to V means M is we are considering as constant. In the next condition, let us take V is constant. Okay, the object is moving with constant velocity. In that case, this P is directly proportional to M mass. And in the next case, let us consider the product of M and V is constant. That is, product of M and V is nothing but momentum. Momentum is constant. Then momentum is constant means we can say the velocity is inversely proportional to mass. So based on this condition, I will plot a graph. So in this case, I will take the momentum on x-axis, velocity on y-axis, directly proportional. Always remember. So here directly proportional means what type of graph you will get means a straight line. So here M is constant. Okay. And in the next condition also, this momentum, the graph between momentum and mass. That means as velocity increases, the momentum also increases. And in the next condition, P proportional to M. Again you will get a straight line. Here which is remains constant means velocity remains constant. And also remember that the slope of this line will give the mass, or here you will get velocity. Then in the next condition, V is inversely proportional to M. V is inversely proportional to M. Directly proportional means, just now I said, you will get a straight line. Inversely proportional means, here let us take mass M and here velocity V. You will get an hyperbolic curve. So remember this graph, which are useful in competitive exams. This is about momentum. After understanding the concept of momentum, next I will explain Newton's second law of motion. Okay. Newton second law of motion. According to Newton's second law of motion, it states that the rate of change of momentum, the rate of change of momentum is directly proportional to the external force, or directly proportional to the net external force acts on it, and the changes takes place in the direction of applied, and the changes takes place in the direction of applied force. This is the statement of Newton's second law of motion. So how to understand this Newton's second law of motion means, let us consider, you know that momentum is m into v, isn't it? Then what is rate of change of momentum? Rate of change of momentum means we can represent it by delta p by delta t or dp by dt. This is called as rate of change of momentum. Meaning is how fast the momentum is changes. And p is equals to m into v. Here m is constant means definitely as v increases, momentum will increases. If an object is moving means its mass remains constant, means if velocity increases, definitely the momentum will increases. So which will increases the velocity? Last class also you have observed that definitely force will increase or decrease the velocity. Then only the momentum will changes, isn't it? So if you apply more force, the velocity increases also more. So similarly you can consider an example. An object is moving with some velocity. Let us consider that velocity is 5 meter per second. So first time you will apply some force. By applying some force, the velocity, that means if you apply some force in this direction, the object is moving in this direction, definitely the velocity will decreases. There is change in velocity. Suppose this object stops in 0.1 second. Okay, if for that you have applied some force, let us say the same object is stopped in 0.05 seconds. First time 0.1 second, next time 0.05 seconds, moving with same velocity 5 meter per second. That means here the magnitude of force you are applying is more. So we can able to say that if you apply more force, the change in momentum will also fast. This is how we can able to understand Newton's second law of motion. The rate of change of momentum. The rate of change of momentum directly proportional to applied force. More force you apply, there will be fast change in momentum you will observe. Then here this force or this rate of change of momentum, dp by dt means what? Rate of change of momentum directly proportional to applied force. You can remove this proportionality constant and you can remove this proportionality sign and you can write it as k dp by dt, and f equals k d, p means mass into velocity, momentum. So this is force also vector quantity, this momentum also vector quantity. Mass is a scalar, you can write like this also, divided by dt. In this expression you observe, if m is constant, if mass is constant, you can write it as f vector is equals to k, m is constant, you can take outside and you can write it as dv by dt, and f vector is equals to k into m dv by dt, rate of change of velocity, that is nothing but an acceleration. F is equals to m into a, here k is proportionality constant. Now we have some liberty to make the value of k is equals to 1. How means? By considering mass is equals to 1 kg. Okay, if we consider mass 1 kg, acceleration 1 meter per second square, by taking unity, then we can give a new unit Up to now we have not defined the unit of force, right? So we can give a new unit. That unit we will consider as 1 Newton. If mass is 1 kg, acceleration produced in that object is 1 meter square, then that force we can say that is 1 Newton. Then here also 1, mass is 1, acceleration 1 means k will become 1. Then if k is equals to 1, we can write F vector is equals to m into a vector, or in magnitude wise we can write F is equals to m into a. So force is equals to mass times the acceleration, mass into acceleration. So Newton's second law of motion means, that is rate of change of momentum is directly proportional to applied force. Here this formula will tell us how to calculate the force. Okay, in Newton's first law of motion, that is defines the force, that gives the concept of force. But what is the importance of Newton's second law of motion? That will tell us how to calculate force. F equals m into a. And remember this derivation, they will ask for 3 marks. Derive F is equals to ma, like that. Now I will define the SI unit of force, that is Newton. So how to define the Newton means 1 Newton. Okay, I will define, it is a force that produces, it is a force that produces 1 meter, that produces an acceleration, 1 meter per second square of an object, or in an object of mass, 1 kg. So that is, let us say this is an object, it is having mass 1 kg. Now I am applying some force. Because of that force, the acceleration in this object is 1 meter per second square. 1 kg mass, the acceleration produced is 1 meter per second square. For that, what I am applying force? No, that force is said to be 1 Newton. Like this we can define the SI unit of force. And remember the dimensional formula. SI unit of force is Newton. Okay, and dimensional formula, that is m l t to the power minus 2. This is the dimensional formula. Then CGS system unit is dyne. Okay, dyne is the CGS system unit of force. Then 1 Newton is equals to, remember, 10 to the power 5 dyne. This is the relation. One more unit is there, that is gravitational units of force. Okay, that is given as 1 kg weight. Okay, 1 kg weight or 1 kg force. So this is equals to 9.8 Newton. Remember all these units, which is important. I hope you understood Newton's second law of motion. Then one more thing, remember, write it as note. So here F is equals to m into a. If you consider mass is constant, the force is directly proportional to acceleration. As the force increases, the acceleration also increases. And you came to know that F is equals to dp by dt. That is from Newton's second law of motion. F equals, here if the force acting on an object is 0, if the force acting on an object is 0 means dp by dt. dp by dt means rate of change of momentum. This rate of change of momentum becomes 0. Rate of change of momentum becomes 0 means the meaning is momentum remains constant. So momentum will not change. So momentum is defined as m into v is constant. If mass is also constant means we can consider velocity remains constant. What does it mean? The object is moving with some speed, okay, some velocity, that is v. If there is no external force is 0, then that object will move with the same velocity. That's what we have studied in Newton's first law of motion. Okay. So Newton's second law explains Newton's first law, so it includes Newton's first law also. So what you have to understand means, if force is 0, no force is acting on the object means the acceleration also 0. Acceleration 0 means the object may be at rest or the object may move with constant velocity. Remember. So this is about Newton's second law of motion. Next, we will study some applications of this change in momentum or Newton's second law of motion. Now I will explain some applications of Newton's second law of motion. So first application, if u and v are initial and final velocities of a particle of mass m and average force acting on the particle in a time interval t is, that means F is equals to, you can write dp by dt according to Newton's second law of motion. Then u and v are initial and final velocities of a particle. So this change in momentum dp also you can write, or you can write delta p also. As t tends to 0, delta p by delta t becomes dp by dt. Now this change in momentum means, remember, final momentum minus initial momentum. So what we have to calculate here, final momentum, and that is nothing but mv minus initial momentum mu. So this is nothing but delta p, or you can write delta p is equals to m into v minus u. So here I written dp by dt, right? You can consider delta p by delta t. Applied force is equals to rate of change of momentum. Then F is equals to, remember this formula, delta p means we came to know that m v minus u by t. This is change in velocity. This is applied force. And here this final momentum, v is final velocity, hence I written final v here, and initial means initial velocity is denoted by u, hence I written here. So change in momentum means, remember, final momentum minus initial momentum. Thus we got, as m constant I taken out, v minus u, final velocity minus initial velocity, that is called as change in velocity. And remember, the changes will occur in the direction of applied force. Then this formula is important in time interval t. This is the force acting on a particle. And in the next application, If a particle of mass m strikes a rigid surface normally and rebounds with the same speed v, the change in linear momentum of the particle is, you can consider a rigid surface and here there is a particle. This particle mass is m. It is moving with some initial velocity. That velocity is v. It is moving with this velocity or speed v, and this particle collides to this surface. Then it rebounds with the same speed. Okay, rebounds means the velocity direction will changes. Rebounds with the same speed. We have to find what is the change in momentum and force acting on a particle. So first, change in momentum, delta p, final momentum minus initial momentum. Always consider this direction a positive x-axis, and this direction minus negative x-axis. Okay, so initially it is moving in a negative direction, finally it is moving in positive direction. Final mv, initially this speed is the same. With what speed it is colliding, with the same speed it is rebounding. Final momentum minus initial momentum. So initial momentum, that is minus I will write here. Why? Because initially it is moving in negative x direction, right? Then the change in momentum, you will get 2mv. That is in this diagram you will get plus 2mv. This positive indicates the change in momentum direction. Here positive negative indicates direction only. In vector quantities, remember the positive sign and negative sign indicates the direction. Here what the plus indicates means the changes takes place. That means the change in direction, the change in momentum direction is away from the wall. And we have to find force. F equals delta p by delta t or dp by dt. Delta p is, we got 2mv. If we calculate magnitude only means that is also you will get 2mv only. 2mv divided by time interval t. Remember this formula. And in next application, if a particle of mass m strikes a rigid surface with speed v with the direction of motion making angle theta with the normal. Suppose this is a surface, this is the rigid surface, there is a particle, this particle mass is m, it is moving in this direction. Okay, this is the direction of the particle and it collides at this point. This is point of contact. Here with the direction of the motion making an angle theta with the normal to the surface. For the surface, this perpendicular line is nothing but normal. So it is making angle theta means it is the angle between the direction of motion and the normal. Then this particle is rebouncing back according to the question. Then also it makes the same angle theta. And we have to find the force acting on the particle, or we have to find the change in momentum of the particle. So it is having mass m. It is moving with some velocity, that is v. Then it is having some momentum, that momentum is p. Here it is rebounding means it is also moving with the same speed according to the question. Then that momentum is p. If the vector acting, momentum is nothing but a vector, if this vector is acting normal or parallel, perpendicular to the surface or parallel to the surface, in that time there is no need to resolve. But it is moving, that means it is colliding to the surface by making some angle theta, right? It is moving at some angle theta. Hence, in this time, what you have to do? You have to resolve the vector into two components. That is in this way. Okay, this is the momentum vector, means this momentum vector is having two components. This is one component and this is another component. Similarly here. So this is the momentum vector, means this momentum vector, it is having one component in this direction and another component in this direction. Observe the diagram carefully. This angle is theta, so this angle becomes theta. Here this angle is theta, in the diagram this angle becomes theta. I hope you have studied a resolution of vectors concept. So here which component, that means this side becomes horizontal component and I will consider P cos theta, and this side becomes vertical component, that becomes P sin theta. And also you know that I cap, j cap, k cap are the unit vectors which specifies the direction. I cap always in x direction, j cap always in y direction, and z, k cap always in z direction. So here also this is horizontal component, this becomes P cos theta. Here momentum before and after is same. Why? Because the velocity is the same, right? So this is P sin theta, and you can consider with direction means minus j cap, negative y axis. Here minus P cos theta minus I cap, that is negative x axis. Here P cos theta I cap plus I cap, positive x axis, minus j cap. I hope you understood this diagram. And next I will calculate the change in momentum, final momentum minus initial momentum. Final momentum delta P vector I will consider. Final momentum is, this is magnitude, this is direction, P along P cos theta I cap. So you know that A vector means you can write Ax I cap plus Ay j cap. In the similar way, here P cos theta I cap plus, but here minus is there, I will write minus P sin theta j cap. Right. Then this is final vector minus initial vector. Initial vector is here. Initial vector, initially it is moving in negative x axis, P cos theta minus P cos theta I cap, negative y axis minus P sin theta j cap. So here final momentum minus initial momentum. Here this P sin theta j cap, minus into minus it will become plus, P sin theta j cap become cancel. But here minus into minus it will become plus, P cos theta I cap, P cos theta I cap. The change in momentum delta P, you will get 2P cos theta I cap. So magnitude only if you want means you will get 2P means mv cos theta. Remember this formula. This is change in momentum. I hope you understood how I got this change in momentum. 2 mv cos theta. For the force F equals delta P by delta T, delta P by delta T, F equals 2 mv cos theta, time interval is T. This is the force acting on a particle according to Newton's second law of motion. Observe carefully here where the momentum is changing. Initially this is a vertical component, right? y component. So y component direction you see, that is downward. Here also y component you see, that is downward. That means here in this direction the momentum is not changing, both vectors in the same direction. But here if you observe horizontal component, initially the horizontal component is in the negative direction, and here this is in positive direction. So there is change in momentum. Vector quantity means direction changes, means also the momentum will changes. P cos theta, P cos theta. So you will get 2p cos theta. Again plus indicates the direction is away from this surface. I hope you understood this concept. Then in the next application you see, in the above case, that means what we have discussed previous application, in that application if we change the theta, okay, if we change the theta angle here, in spite of taking with the normal, now I will take that angle, I will consider that angle with the surface. Then what happens? Then what happens means, if I consider this angle is theta, you read that question carefully, this angle is theta, if I consider angle theta is this one, then this will not become theta. From this diagram, now it will become theta. Then this will become cos component, isn't it? P cos theta, and this will other component become P sin theta component. So similarly, here also, if you consider this angle as theta, it will not become as a theta angle. From the diagram, this will become theta. Again, this is cos component, P cos theta, and this is a sin component, P sin theta. Now just I am interchanging sin and cos. In the problem also, you have to interchange sin value and cos value. Finally, you will get 2p sin theta, and here also finally you will get 2mv sin theta. The final answer you will get 2mv sin theta divided by t. Remember, don't confuse. If you consider the angle with the normal, 2mv cos theta. If you consider theta with the surface, 2mv sin theta. That is change in momentum. And in the next application, from a nozzle of area of cross section A liquid of density D issues out with a velocity V horizontally and strikes a vertical wall. Then if water does not bounce back, you can consider this is the rigid surface. Okay, in this rigid surface, from this pipe, let us consider the water is coming out and it is colliding to this surface with the speed V. First condition, the water drops is not rebouncing back. That means final velocity is 0. So here first I will calculate the change in momentum delta P. Change in momentum delta P means final momentum minus initial momentum. Final momentum is 0. Initial momentum, that is final minus initial, m into v. You will get minus mv. If we want only magnitude means the delta p becomes mv. This is change in momentum. Also we can express this expression in this way. Mass is equals to density by this one. Density is equals to mass by volume means mass is equals to, you will get density into volume, where d is density. Then m is equals to this d, volume we can able to consider as this area and this distance, that is x. Then I will substitute here the change in momentum delta p, that is equals to, in the place of m, a d x into v. Here this v is volume, this V is velocity. If I want to find the force, that force is equals to, I can able to write delta P by delta T. So this equals, delta P means A d x V by time interval T, then x by T also you can consider it as V, distance by time, then A d V square. This is the force exerted on the surface when the drops will not rebounds back. If the drops will rebounds back with the same speed means, then here the final velocity you will not get 0. That final velocity also you will get m into v. So if the direction is negative side, minus m into v, minus into minus, you will get minus 2 mv. Okay, this is change in momentum. Finally what you will get means, final answer you will get, that is force equals, here also 2 adx, finally you will get 2a dv square. So I hope you understood these applications. Okay, in the next class I will explain some more applications and some common forces used in mechanics. Thank you.